So there are just a few more related functions. So we just talked about pivot. There's a related function that's a little more generalizable called pivot table. So this is a generalization of pivot that can handle duplicate values for a index column pair. And just as with pivot, the levels will be stored as a multi-index object on the index and columns of the resulting data frame. And we will see an example of that in a second. There's two other functions that are related, and we covered these a few weeks ago, or a few lessons ago, but I want to revisit them here because they really fit better with this lesson. It's stack and unstack. And so what this does is takes a data frame and converts it into a series, a multi-index series. So, and stack and unstack are very similar. You're going to take all the values in the data frame, and the first level index will be the row names, and the second level index will be the column names. With stack, it's the column labels that come first, and then the index labels. And with unstack, it's just the opposite. It's basically taking that a data frame is like a two-dimensional table, right? You're going to take all the rows or all the columns and just stack them on top of each other. And unstack is a confusing name, but it just means stack, but in the other axis. Like instead of stacking like columns on columns, you're going to stack rows. You're going to take each row and rotate it, and then stack rows on rows. So you're going to end up with a 1 by n series that then has the multiple indexes corresponding to the rows and the columns. This should all become clear in a minute when we see some examples. So what we're going to do is we're going to play around with this Earth Microbiome Project metadata that you just recently did your last homework on. And so we're going to want this data in the data folder. If it is, this command will work. If not, you'll get an error like I just did. So if you get this error, we just need to go to open up a terminal. And go to data, and I'm guessing that your copy of this file is, well, I don't know exactly where you would have done your homework, but probably the easiest thing is we'll just download the raw file. So let's go back to GitHub, go to the main repository, data, click on that mapping file. It's a little bit big, so we're just going to download it. There we go. We're going to copy that link. curl-o. Copy and paste that to our terminal. Okay. Alternatively, if you know where that file is, you can copy it to this data folder. Or, if you want, you can, in the notebook, you can change the path to wherever that file is on your computer, and it'll work too. It just needs to be in a place where the notebook can locate it. So this is just that file of metadata for 2,000 samples of the EMP data set. So we're going to, again, we're going to read CSV. This is a TSV, or tab separated value, so we have to say sep equals tab, which is a \t in quotes. And so if you recall from the assignment, this has a bunch of columns, there's a bunch of metadata about these samples. We just want a subset of that. So we're going to pass a list of the sample ID, the study ID, number of observations for the dBlur 90 base pair table, the latitude, the longitude, the temperature, this EMPO, this EMP ontology thing, and this ENVO ontology thing, which is this is basically the microbial environment and the biome. So now if we look at that thing, we can see that we've got just a smaller table with just these 1, 2, 3, 4, 5, 6, 7, 8 columns. Now there's a bunch of NaN values for temperature, a bunch of missing values for temperature data. So what we're going to do is only get the rows with temperature data. So we do that by saying df.temperature degrees C dot not NA. So this will return true for rows that have a non-NA value in the temperature column. We then apply this masking. So we use we put that all inside square brackets, and then use that to get just the rows of the data frame that have true in that row. So it'll only give us those rows, and then we're going to do one more thing. We're going to reset the index. So we did this before. We're going to reset the index, and we're going to say drop equals true. So what this will do is it will drop the old index and not keep that. So we don't want these old numbers. They don't mean anything to us. So we're going to remove those. And then we're going to store the whole thing as df again. If we run that and type df, we can see that we now have, when we scroll down, we can see that there's 411 rows, so it's indexed. We have this new index now from 0 to 410. If we had not done the reindex, we'd still have these old index values, and there'd be a lot of missing values, and we can just reset the index. Also, you can see that the temperature now has all numerical values, and so we now have a 411 row by 8 column data frame that we can do stuff with. So one thing we can do is melt it. So we can say we're going to have our ID variables be just the sample ID and the value variables be some of this numerical data. And so we will now have a column corresponding to sample IDs, a column corresponding to variables, and then a column corresponding to values. So there might be a case, say, if we wanted to do some plotting or just have a different way to access the data, that we could summarize the data using melt like this. We can also pivot the table. So we can say we want our indexes to be this EMP ontology 3, this sort of microbial environment type. The columns would be the biome, and the values to be latitude. And because there are going to be multiple combinations of EMPO3 and ENVO-biome 2, we have to specify some function that will happen to those values. So the default is mean, but I'm just specifying it here. So we're going to average the values here. So it's going to give us a single value for EMPO and ENVO, and so these are the unique combinations of the microbial environment type, or the microbial environment type, and the sort of more traditional environment type, so like forest biome, marine biome, etc. These are all the samples that have temperature data, and now we're looking at the latitude, and so this is giving us the average latitude of all those samples. So we can see, in our data, the for the surface samples, the latitude of the samples from the terrestrial anthropogenic terrestrial biome is higher than from the forest biome. You could probably come up with a more interesting question to ask with this kind of approach, but this gives you an example of how we could pivot this data using this function. Okay, finally we're going to cover stack and unstack. But before we do that, we're gonna make a few modifications to our data frame. First thing we're going to do is we're going to take this numerical index that we have and we're going to put the sample ID in there. Now we could have imported the data frame with the sample ID as that index column, but since we didn't do that, we're going to do that now. So we're going to say df.index equals df sample ID. So now we have the sample name or the sample ID as our index, and we still have this column called sample ID. So the name of our index column is called sample ID, but we also have this other column name called sample ID. So that's undesirable. So what we can do is we can drop this column that we had before. So we can do df.drop. And we're going to drop sample ID, and we have to specify axis equals 1 because by default drop works on rows. So that would be axis equals 0 for this function. So to drop columns, we say axis equals 1, and then we say inplace equals true, which means do this operation and then change the data frame. So it would be analogous to leaving this part out and then saying df equals this part. But since this function gives us this inplace equals true, that change will be made in place. And now we've dropped that sample ID column. So we now just have the sample ID index and then the rest of the data. Okay, so this is useful because we're going to want those sample IDs as indexes, because the way that stack and unstack work is they use the column headers and the row indexes as the new hierarchical indexes for a series. So we're going to do df.stack, and we're going to just store that as a new object, which is actually a series. We're going to call that df_stack, just so we can play around with it. So when we create that new object and look at it, we can see that the notebook renders it more as this like text display instead of a table display. That should instantly tell us that it's a pandas series. But if we type parentheses df_stack, it will confirm that that's a pandas series. And you can see that it's got this multi-index. So we've got the top level index is the sample ID, and the second level index are the former columns of that data frame. So what we've done is we've taken this table and just stacked all the values, and you can see that these values are all different kinds of things. There's integers, there's floats, there's strings or objects. So the type is object. It doesn't have any individual type. But when we then pull out a value, we can specify. We can sort of sandwich these indexes together. So we can pull out. In fact, I want to add something here. So we can pull out just the data for this one sample. So, we could have done that using the data frame, but the advantage here is that we have ability to get individual values from there using the by combining these indexes together. And so so even though this series effectively is considered an object, when we pull out the actual values, it recognizes that it's a floating point value. There's many ways to deal with hierarchical indexes. So we can sandwich the top level index and the second level index together like this, or we can use .loc, so the label-based indexing. So this would be sort of like row column, but instead we're just providing the first level and second level index, and that works. We can actually omit that loc and just type the first comma the second, and that works too. So Unstack is the question. If you wanted the
So like instead of specifying the one sample ID, say what if you wanted all your
yes, so it should work like that. But another option would be, so I mean, you could also just leave it as the data frame and just get right. You could have done you just could have done that. But there might be cases where using stack is more efficient. I mean, it makes more sense. Probably makes more sense with uniform or homogeneous data frames where every column is the same type of data, like, and you wanted to just let's say you had like dates on your indexes. Your rows were dates, and your columns were like locations, and you had like temperature data from all over the ocean, and you wanted to do something with all the data together. You could stack it, and then you could do like statistics on the whole data set, for example, instead of by or depending on I think it just gives you more flexibility with how you handle your data, whether it's in a table or whether it's in a single list. But to answer your question, you could also do this, where you could use the unstack function instead, which just inverts the order of those indexes. So when we do unstack now, this will this work? Let me make sure this is doing. Yeah. So with unstack, it's a little hard to see on my screen, but it's giving us this extra study ID as the as another index, or not another index, just another label. But we can then okay, sorry. Everything is cool. It just that I forgot that study ID was one of our other data columns. So you can't see it here, but temperature is one of these first level indexes. So instead of doing the sample name and then the variable that we want. We would do the variable name first and then the sample name. So in this case, we can do temperature and then the sample name. And again, we can use .loc with commas between them or just commas between them by itself. And if we wanted all the temperature data, we can just do that, and that'll give us everything as a single column with a single single level index, whereas the stacked or unstacked object has a multi-level index. So there's a lot of different ways to pet your cat, as you can see, and a lot of different ways to do similar things or do the same thing different ways, and it kind of just depends on what you're trying to do. What's most reasonable to you, and what applies best to your situation, and if you're going to do some plotting or some other downstream application. So that's sort of a quick summary of group by operations or group operations, including group by, melt, pivot tables, stack, unstack, and just as you use those more and more, you kind of get more familiar with what they can do. So that's all for today. Just to orient you for the rest of the course. We'll talk about some statistics next week and interactive visualization, and then modules and classes to package your code so others and yourself can reuse it. And then we'll have some Git and GitHub on the last day, which is, of course, how we've been managing the course thus far, but you haven't had the chance to really use it yourself. So we will cover that, and then that last week, the final project will be assigned, and then do the following week during finals.